1 over 2, 2 over 5. You are looking for the 10th term, right? So since the harmonic sequences, we have the reciprocal of the given. So we will have the first number, A1, will be 1, because 1 over 1 is still 1. The reciprocal of 2/3 is 3/2. The reciprocal of 1 over 2 is 2 over 1, or 2. What's the reciprocal of 5 over 2? 2 over 5 is 5 over 2. And so on until to the a sub 10. Okay? So in order for you to get the a sub 10, we will be applying our rule. A sub n equals a1 plus n minus 1 times d. Okay, we have the a1, but we don't have the common difference. The common difference that you will subtract each. So 3/2 minus 1 is what? Half. 2 minus 3/2 is half. 5/2 minus 2 is half. So the common difference is half, or 0.5. Okay? Or half. It's up to you. So let us try to get the a sub 10. A sub 1 is 1 plus n minus 1, which is 10, minus 1 times half. So 1 plus 9 times half. 1 plus 9/2 is equal to 2 plus 9 over 2, which is equal to 11 over 2. That is your reciprocated value of the 10th term. So therefore, our a sub 10 is, Rainier, what's the value?
Sir.
What's the
2
value
over
of
11.
2 over 11? We will get the reciprocal of, so 2 points for this. Who got this answer? Who got the answer? Gab, he got it. Very good, Gab. Rainier, 2 over 11. Who else? JL, great. Hanan, great. Okay, who else? Michelle did not get it. Okay. All right. Number 10. What about number 10? What is the answer on number 10? Is that n is equal to 1? JL, will you give me the answer on number 10?
Sir, my answer is... Wait, let me find, sir. So my 1 is equals to 3.
Your 1
Sir,
is
but I'm not sure because it's n equals 1, so
it's
it could
supposed
be
to be
n.
6 over 7, right?
Yes, sir, but it says that n equals 1, so maybe it's going backwards.
But the given are, what are the given? For each harmonic sequence, find the nth term. It is the first term. So that is the nth. Maybe they just had a typo error, because the given is 6 over 7. This means to say that the first number is 6 over 7, right? So it means to say that if you are going to solve this, the n over 7 is, the first is 6 over 7 already, right? So let's skip that and just put it as bonus because it's not actually clear what they are asking. But if you will be going to answer that, it is actually a sub 1 is 6 over 7, right? Because the nth term that they are looking for is number 1. Okay, next, number 15. Solve the following. Determine the common difference between the terms of the harmonic sequence a sub 3, a sub 3 is equal to 1/4. It's not writing. There is a problem with my board. Okay, I'll stop it first. Okay, so it is on case number 3. Okay, case number 3 has y squared is equal to 4px. So you know that when it's y squared, it is either opens to the right or to the left. When p is positive, then the value, I mean when this is positive, then it is opens to the right. So let's get the equation. Y squared is equal to 4px. So we will equate the two, 16 and 4p. So 4p is equal to 16. So we'll divide 4 both sides. So p will be 4. After that, we have to get the value of our focus. The focus is at p0. So since we have our p, which is 4, so the focus will be at 4, 0. And then our equation of the directrix is the opposite of the p. So therefore, directrix is x is equal to -4. And our principal axis, definitely the y-axis, or y equals 0. And the endpoint of the latus rectum, okay, endpoints of the latus rectum, we have P2P and also we have P negative 2P. So therefore, we have the endpoints of the latus rectum. P is 4, 8. So the other one is 4, -8. So we completed all the information that we can graph our parabola. So when we have okay, so let's graph. Let's start with the focus 4, 0. 4, 0. Next, the directrix is -4. So this is our directrix. We have our 4P. The vertex, definitely it's at the center. The origin, so 4, 8 is here. And the other one is 4, -8. -8. So let's graph. So focus at 4, 0. And then these are the latus rectum 4, 8. And -4, 4, 8. Positive 4, 8, negative 8. Okay, so this is our lattice, this the directrix. At x is equal to negative 4. Did you understand number 3? Did you understand number 3? Okay. Clear. Now let's go to number 7. X squared equals 6y. So I should erase this. So our format should be on each case. So definitely you have to look at the given so that you can be able to know which case you will be going to use. All right. So we have the given, which is x squared. So I will make it 6y. Right, so I'll erase this first. So take a screenshot already after discussion so that you can be able to save, okay? Right, next we have, so which case, so you have to refer on the x squared. So which case do we have? It's positive. So which is on case 1. Right, so case 1 has the formula of x squared equals 4py. So we need to get our p. So 4p is equal to 6. We need to equate these two. So divide both sides by 4. Therefore, p is equal to, divide by 2, it's 3 halves, or 1.5. So our focus now is 0p. So therefore, we have 0 and 1.5. Now we have our directrix. Directrix is at y is equal to negative p, so negative 1.5. And our endpoints of the lattice rectum, we have negative 2p, p, and 2p, p. Okay, so we have the endpoints negative 2 times 1.5 is negative 3 and 1.5. 2p, 3, and 1.5. So let us now graph our parabola. So the focus is at 0 and 1.5. So 0, 1.5 is over here. And then the lattice rectum, negative 3 and 1.5. 3, 1.5. The directrix is at negative 1.5. So y equals negative 1.5. So let us graph now. It's over here. So this is our focus, which is 0, positive 1.5. And here we have 3, 1.5, and negative 3, 1.5. Okay? Easy, right? Now let's go to number 10. Number 10. So we will erase this again. Now we're number 10. Number 10 is x is equal to negative half y minus 4 squared plus half. Okay? All right, so we will move this to the left side. So it will become positive half y minus 4 squared equals negative x plus half. But since there is a half here, we will be multiplying both sides by 2 times 2 times 2. So cancel out. So our new equation is y minus 4 squared equals negative 2 open bracket x minus half. Because we factorize the negative. Negative 2 times negative 1 is this. It's 1 actually. Okay? And now, let us go now to our cases. So since the y has a power of 2, so, and this is negative, so we are on case 8. Because this is negative. So since we are on case 8, so this is our formula. Y minus k squared is equal to negative 4p x minus h. We will rewrite our formula here. Y minus 4 squared equals negative 2 x minus half. So obviously our k is 4. Our h is half. So h is half and k is 4. And to get the p, we will equate these two. Negative 4p equals negative 2. So we will divide both sides by negative 4. So therefore p is equal to half. Okay? So let us now we got the vertex. The first one is the vertex. Vertex is at half and 4. Now let's get the focus. The focus is at h minus p and k. So the h is half minus the p, which is also half. And then the k is given, which is 4. So therefore, the focus is at 0 and 4. Okay, so we got the vertex, we got the focus. Now we will go to the directrix. The directrix is h plus p. X is equal to h plus p. The h is given, which is half. The p is also given, which is half. So half plus half is 1. So the directrix is at 1. Now we have principal axis is the k. So k is equal to 4. That's the principal axis. And then the endpoints of the latus rectum, we have h minus p and k minus 2p. So h minus p is, h is half, minus the p is also half. The k is 4, minus 2p, 2p is half. So therefore, we have 0 and 4 minus 1, which is 3. Next, we have the next part of the latus rectum, which is h minus p plus and k plus 2p. Okay. So simply same thing here. This is 0. And we will add this 4 plus 1 will be 5. Now it's complete. We have the vertex. We have the focus. We have the directrix. We have the endpoints. And also we have the principal axis. Okay, so let us now graph to our given grid. So I will be graphing now the vertex. The vertex is at half 4. Half and 4 is here. That is the vertex. The focus is at 0, 4. 0, 4. This is the focus. Since it is actually opens to the left, so the graph is turning to the left. And our endpoints are 0, 3 and 0, 5. And our directrix is at 1. So 1 is here. So it's exactly halfway. And our graph of the parabola is opens to the left. Yes, so this is the focus. This is our vertex. This is our endpoints. 0, 5, 0, 3. This is 0, 4. And the vertex is at half 4. Question. Now, is it confusing, John Ramsen?
Sir, it's a lot.
Why? Still
It's
confusing.
very...
Sir, yung number 10, sir.
Sir,
Oh
can I
my God.
picture, sir? Sir, okay na yung dalawa, sir, eh. Ito lang, sir, eh.
Why it's still confusing? We have more on standard form.
Sir, can you go to the graph po, sir? Sir,
Okay,
sa graph po, sir.
I'll make it a little bit bigger. Okay. Now let us try this example here. Okay. Number 21. Okay, number 21. You have to put it in the standard form first, and then after that, you have to identify which case it will lie, okay? It lies on our cases with the vertices. So let's try x squared minus 6x is equal to y minus 11. So I put the negative y to the right side, became positive. Now, by completing square, we will complete the square. We will get the b, which is 6 divided by 2 is 3. Then square it, it's what? It's 9. So we will add 9 left and right. Plus 9 here, plus 9 here. Then after that, we have x squared minus 6x plus 9 equals 9, or y minus negative 11 plus 9 will be equal to negative 2. And then we will factorize this. So it will become x minus 3 squared equals y minus 2. Right? So meaning that this is 1. So which case is x minus 3 squared equals y minus 2 lies on our cases? Which case is this? It's positive. So this one case number 5. Yes. Okay. So we will copy that. X minus h squared equals 4p y minus k. Okay, now we have our equation x minus 3 equals 1 y minus 2. So we can identify the vertex hk. So where vertex is at h and k. So the vertex is at 3, 2, h and k. So the h is 3 and then the k is 2. The next is that we have to get the value of p, right? So we will be equating this to 4p is equal to 1. Divide by 4, so p is 1/4. After that, we have to get the value of the focus. So what is the focus formula? So the focus is at h and k plus p. So our focus is the h, which is 3. K plus p, so 2 plus 1/4 is 2.25. So we will do it on decimal so that we can be able to graph. Because 1/4 is 0.25. So when you add 2 plus 0.25 is 2.25. That's the focus. Now directrix. The directrix has a formula of y equals k minus p. Okay. K is 2 minus 0.25 is equal to 1.75. That is our directrix. Now, let's get our principal axis is h. So therefore, x is equal to the h, which is 3. Now we will get our endpoints of the latus rectum. Okay, EPLR. So h plus 2p and k plus p. Right, what is our h? H is given, which is 3. Plus 2p, the p is 1/4 times 2. So it will become 1/2 or 0.5. And then the k value is 2 plus 0.25. So therefore, we will be having 3.5 and 2.25. At the same time, we subtract this, it will become 3 minus 0.5 will become 2.75. And then 1 plus 0.25 is 2.25. That's 2. Okay. So everything is complete. Then we have to graph it now. This is the same process. As long that you know the cases, then it's easier for you to solve it. So let's try to graph now. So we have the vertex is at HK, which is 3, 2. 3 and 2. Now we have the focus is at 3 and 2.25. 3 and 2.25, it's here. That is the focus. It opens upward. And our endpoints of the latus rectum, 3.5 and 2.25. 3.5, 2.25. Where is 3.5? Here. Then 2.75 and here. Okay, so this is our graph going up. It's a small only. And our directrix is at 1.75. So this is our directrix. Okay. And that's it. Do you have any question? How to solve? Ramsen, still confusing? You have to get the correct cases so that it's easier for you to do.
Sir, why do we have to go to that much trouble when it's just that small parabola, sir? It's so small.
Okay. Again, force is mass multiplied by acceleration. So a mass is 15 kilograms and a 2.4. So you multiply, so you will get 36 kilograms meters per second squared, which is equivalent to newtons, right? So that is the multiplication of a scalar and a vector, right? So now let's do 2.12 practice. So the restoring force of force F acting on the spring with a force constant K when stretched or compressed to a displacement X. So this is the displacement X from its equilibrium position is given by F equals negative Kx. So if a spring with a force constant of 22 newtons per meter is compressed to 0.5 meters to the left, as shown in the figure, what is the compression force applied to the spring? All right. So that is a constant. This is 22 newtons per meter. So we have the formula force is equal to the Kx. So the given force, the given is the spring constant, which is 22 newtons. Since it is to the left, over Newton per meter multiplied by 0.5. So we have 0.5 meters. So we need to cancel the meters. Then negative 22 times 0.5, it will be what?
Negative 11.
Negative 11.
So that's the force going to the left, right? Given by this formula. Okay? So let's go now to the next. It's just a formula. Dot product. The dot product of two vectors A and B is called scalar product. Although two vectors are being multiplied, the product is scalar quantity. The dot product is given and defined as A dot B is equal to AB cosine theta. So you know that when the angle is attached on the horizontal, then we are going to use the cosine. The product of A and B, okay? Where theta is the angle from 0 to 180 degrees between A and B. The dot product may be viewed as the product A and the projection of B along 2-7 picture. The dot product of two non-zero vectors may be positive, negative, or zero, depending on the angle between them. Since the dot product of two vectors is a scalar, then the dot product is commutative. That is AB times BE. So it won't change the product. A familiar example of a scalar product is work. Work is a force in a distance, right? So remember that when you are trying to push a certain object with a certain distance, then there is a work being applied. All right. Imagine you have to push the wall and nothing happened to the wall. Do you think that there is a work had been done on the wall that you pushed? There is a force, but there is no distance or displacement. Is there a work that is being done when you push the wall? Nothing, right?
No.
So no work has been done because there is no displacement. So that's why a work is a force multiplied by a distance. Okay? And it is, of course, it is on joules. Newton meter is a corresponds to 1 joule, right? It's Newton meter is a joule. Example, how much work was done by a man if he exerted a force of 5 newtons inclined 30 degrees with the horizontal surface and succeeded in moving his luggage by 2 meters. So it's very easy. Remember that a force, work is equal to force multiplied by the distance. But since this is the work, the displacement that's being done, and it's lifted definitely with an angle that's 30 degrees. So with reference to the horizontal, then we have to use the cosine. All right. So force is 5 newtons multiplied to cosine 30 times the distance given, which is 2 meters. So what is the value? So 5 times
7.
cosine 30 times 2. So it is 8.7 joules. Okay? Easy. Let us try the practice exercise 2.13. Julia, will you read exercise 2.13?
Object was moved 12 meters along a rough horizontal surface. How much work is done by a friction force caused by the roughness of the surface of 5.0 Newton? Note that friction is always opposite the direction of motion.
Okay. So therefore we have work is equal to force times distance. So we have force is 5 newtons
Newton,
multiplied to cosine
12 meters.
times 30 times 12, right? It's 12. Okay, so an object was moved, work must have has been done. So it's just like when you are pushing something like, for example, this is the mouse. Okay, just look at it, and I'm pushing the mouse over there, right? So there are constant frictions that they use, like they use like metal to metal, concrete to metal, a wood to metal, right? That's why this friction, it causes, sometimes it's so hard to push an object because of the roughness of the surface. All right? So there are actually specific kinetic friction that they use, and that is being actually denoted by this symbol. But since we don't know the object, if it is a wood or it is a concrete or it is a metal. So by this time we can be able to multiply this 5 times 12. So that's why the work has been done is 60 Newton meter or 60 joules, right? So soon you will be encountering, like I will be giving you given, like if it's from metal to concrete, concrete to plastic, or something, an object that's different from each other. That's why, have you imagined like when the surface, when the floor is rough, it's so hard to push or to slide an object, right? There is no friction, and it's so easy to slide the object when the surface is smooth, right? Even when you are in your room, when you are about to transfer the places of your cabinets, of your furnitures, it's easy to slide sometimes when you put paper under the bottom of the cabinet, or the bottom of the cabinet, right? So those are frictions that causes sometimes, it made the objects hard to move. Okay, so that's what we have on our work. Force in a distance is a work, and it is determined by Joule. Cross product. The cross product of two vectors A and B yields another vector. It is for the reason that the cross product is called a vector product. The vector product of A and B is written by A and B. Its magnitude is given by AB sine theta. And when it is actually from 0 to 180 degrees between A and B. So the magnitude of A and B is AB sine theta. Now we are pertaining to the vertical, right? Before it was horizontal. Now, we have, as shown in figure 2-8, sine theta is in the component of vector B, correct? It's on B. And then that is perpendicular to vector A. Then, hence the magnitude of the vector product can be viewed as the product of the magnitude of vector A. And the component of vector B is perpendicular to vector A. The right-hand rule determines the direction of the vector product. With your right hand, point your index finger, so try it, point your index finger along a vector A, and point your middle finger along the vector B. It's moving towards, move your index finger to the direction of the B. Look at that. The thumbs gives the direction of the cross product. Note that the cross product is not commutative. Reversing the order of the vectors give the same magnitude but in opposite direction, right? So they are not commutative. When you multiply AB, it's not equal to BA because they have different direction. The cross product of vectors A and B is a vector that is a perpendicular both A and B, but not that A and B need not to be perpendicular to each other. If A and B are parallel or anti-parallel, which with each other, then the vector product is 0. The vector product will be very useful in our study of electromagnetism. So we will use that right-hand rule when we will go on electromagnetism. So there is a coil of wire that will be actually used on those. Okay, let us try this torque. Sample 2.14. Torque is the ability of the force to produce rotation, right? So you are familiar about the torque. Okay, torque is presented by this symbol. It's like T is defined as the cross product position of the vector R from the axis of rotation to where the force F is applied and force vector F itself. So that's why the torque has a formula of R times F. The pole is 4.2 meters. R is like a radius. This is like actually a swinging thing, or it's like, you know, what they call
Barbershop.
What they call, if I have a torque and they will put a radius and it will rotate going over there on that position. right? So horizontally, and it's being acted upon by an upward force of 5 newtons at one end. Find the torque produced by the force if the pole free to rotate about the other end. Okay, you know the fan, right? It's like this. So this is like a torque. And when you move over there, it will have a rotation going left or going to the right, right? It's like this. So that's the torque. And it's like a circular thing. When you move it, that's why they call it radius. Okay, so it's R. So there is a pivot
They're like a
origin.
windmill.
A windmill, it can be, but the windmill is a full rotation, right? Like this. But a torque is only half like this. That can be moved. Half of the windmill, it's a torque that's moving.
Like a windshield. Is that what you call it?
Yeah, windshield can
For
be.
cars?
It's the torque, but it should be straight. Okay, not like this. It should be straight line. Okay, so when you have a pole that is 4.2 meters, gate also they have torque, right? The gate, the door,
Yes, sir.
right? So those are the things. So 4.2 meters long is positioned horizontally and is being acted upon by an upward force of 5 newtons. Also in the, what do you call, checkpoints, right? You have torques on the checkpoints. They will move it up like this, going upward force.
There is it like wrench? Like your wrench?
A wrench, yes. But it is fixed over here so that it can hold to move it upward. You know the checkpoint, the barricade for the checkpoint. So when you enter the gate,
Yeah.
so they will put it up, right? So that is a torque. Okay. So find the torque produced by the force if the pole is free to rotate about the other end. So we have the formula. Since we are using, it is perpendicular to the force, we are using 90 degrees always. Okay? So 90 degrees. So just only multiply torque is equal to the product of the radius times the F multiplied by sine 90. So you know that sine 90 is 1, right? So it doesn't it doesn't have a bearing. So just simply multiply that 4.2 times 5. Then you will get this 21 meters Newton. Okay, so that is the torque pointing of the page of the paper is given by the right hand rule. Okay, so since it has a distance, that's why it has a meter Newton. That is a torque. So let us try to answer this. So just only multiply a pole 4.2 meters long along the x-axis being acted upon by a force of 5 newtons along the x-axis. So find the torque produced by the force of the pole. It's free to rotate about the origin. So just only multiply torque
4.2 times
is
5
equal to
times
4.2 times 5 times sine
90.
90.
So it's the same as the one on
It's the
top?
same, sir.
Yes, it's the
21.
same. 21.
Sir, is 90 constant?
Yeah, it's constant. Anyway, it's sine
So
90 is 1. So no bearing. But sometimes
So could it be
sometimes they give sine 180. Yes. Or it is only until here. 45 degrees. Right? So there is a control.
like the one on checkpoints?
Yeah. Okay, so the value is, the torque is 21
21 meters per Newton.
Okay, so let us revise the formula that what we had. We have momentum is P. Okay, momentum is represented by letter P. The product of mass and velocity is momentum,
Acceleration.
and it is on kilograms meters per second. Then we have force is the product of
Mass times
mass
acceleration.
times acceleration. It is on
kg.
kilograms.
M squared.
What?
Kg times m squared. Meters per
M
second
over
squared.
squared or newtons, right?
Newtons.
And also force work.
Whole.
Work is
Force.
force in a
Force times
distance.
distance.
So that is Newton meter.
Meters or
We have
joule.
also spring constant.
So it's also joule, right?
It's also joule. What about
What is it?
the spring? Negative
It's
kx
negative kx.
is, what was that? Let's go back. Um, the spring constant, we forgot it already. F also, yeah.
F, sir.
Yeah, it's also F. It's also a force. And then the spring constant is on Newton over meter. And then X is also meter. That's why I need to cancel. So the force is newtons.
Newton.
We have also horizontal component of the what?
Product.
The product, it has cosine, right? So
Yes, sir. Cos.
so that's
You're
also
looking
a
for
force.
the adjacent, the horizontal thingy.
Yeah. So the horizontal component with x.
So it's vector A
multiplied
times
to
vector B.
cosine angle, right? And also F, which is the y cosine sine 90. So it's a matter of formula only. Those are products. So don't forget this.
Sir, in which course are these needed?
For engineering courses, you know the engineering courses, they have a lot of physics subject. Physics 1, Physics 2, Physics 3, Physics 4. And
So we need this to build stuffs.
In where?
Build stuff.
Yeah. Buildings for engineering courses. Also in for marine engineering.
So how about
And
aeronautics?
Aeronautics also, most especially. You have a lot of physics
Really?
subjects. Math and physics subjects.
In aeronautics, sir?
Yeah. When I was studying, since my major was math, so it was easy because I don't need to memorize many things. I just can bring a calculator and a pen, and that's it. But unlike for those who
Is
are
it open
studying
formula?
nurse, sometimes, but not all the time. Like when you go on board, like when you have a board exam, you don't have any formulas to use, so you have to practice. It's not actually about memorization, but you need to practice, right? Most especially in physics, you have a lot of formulas like this. And it is important to know this because this will derive you on the exact unit of the given, of the unknown thing, right? It's the exact, like kilogram meters per second or kilograms meter per second squared, that corresponds to Newton. So I will know that the force has a value of Newton. If I have different thing here, then for example, the mass is on grams, right? So I cannot multiply the grams on the acceleration because I cannot get Newton on that because Newton is kilograms meters per second squared. So I need to use as conversion table first in order for me to get the correct unit of that, right? So that's why physics and math are related. So if you hate math, you will be hating physics too.
Sir, can you give us like